Hello, my name is Laura Serra. I have a degree in mathematics and a PhD in statistics. In this video, I'm going to talk about linear regression, a basic and commonly used type of predictive analysis. The main goal of regression is to explain an outcome variable depending on others, and in what way do they impact the outcome variable. The R program can be installed in different types of operating systems: Windows, Linux, or Macintosh. The download can be done from the website. For installation in Windows, just choose the Download R for Windows option and click on the base subdirectory that will appear below. Then, you just have to continue with the options that are provided by default. Once the installation is finished, the program can be executed from the icon that will have been generated. Once you have entered the program, you can write the instruction directly to the console, the white screen that appears when the program opens. Anyway, I would recommend working with RStudio because it's a more pleasant environment. RStudio is an integrated development environment for R that allows the user to use R in a much friendlier work environment. The download can be made from the website, or selected the RStudio desktop, and open source edition options. You will see that first, you need to install the latest version of R. If you have not installed it yet, you can download it from this web page. The program can be executed from the icon that will have been created. The RStudio screen looks like this. In the RScript data view window, we can write and save the instruction syntax. In the console, we can also write the instructions and see the results. The Environment tab shows all the objects that we have saved or those that we have been creating throughout the session, and the History tab shows the list of instructions used so far. Finally, down to the right, the Files tab shows all the folders and files that we have in the working directory. If we have not defined any working directory, it takes the root by default. The Plots tab shows all the graphics that we are doing. The Packages tab allows you to see a series of packages or functions that we need to execute certain instructions. They have to be installed previously. The Help tab is useful for additional information. Then, the instruction can be written either in the RScript data view window or directly in the console window. We recommend, however, the first option because in this way you can save the instructions for later use. The RScript data view window is a text editor. To execute one or several instructions, they are selected with the cursor and then Run button is pressed. Or you can also press Ctrl-R or Ctrl-Enter at the end of the line. The executed instruction appears automatically in the console window, colored usually in blue. In the console window, under the instructions, the result will appear in black, but if it is a graphic, it will appear in the Plot tab of the Files Plot Packages Help window. To create a new RScript syntax file, you can either go to File, New RScript, or press the icon with the plus sign and select RScript, or simply press Ctrl-Shift-N. Be sure to save the script by clicking the icon that represents a disk. As long as it doesn't, it will come out as untitled. First of all, it's important to point out that R distinguishes between lowercase and uppercase, so care must be taken. Then, if you write log in uppercase, R will not recognize the logarithm function. R is a data analysis program. Therefore, in order to work, the first thing to do is to enter new data, either directly through the console or by importing an existing data file. The import of the data can be done in 3 different ways. Import the data from an existing file, import the data from an existing file already in R, or import the data from existing libraries to R. To import data from an existing file, as we will proceed from now on, you must specify the directory or folder on which you will work. It's important to have all the information in the directory to avoid having problems when calling the files. It's advisable, therefore, to decide the unit on which to work and create a new folder there to store all the information necessary to perform the analysis, databases, GPG files, etc. The syntax that is required to specify the directory is this instruction. And to see what is our working directory, we write this instruction. Once the work directory is specified, you can import data from different file types. Text files are imported using the read point table instruction. To import an external file in SPSS format, you need to load the foreign library. It is an internal library of R, and this means that you can call directly with the library instruction without having to do any previous installation, and then write the instruction read.spss. To import a file in a static format, you also need to foreign library and write the instruction read.dta. There are several libraries that allow you to import a file in Excel format, but some, such as XLSX, Excel Connect, GData, etc., do not work properly. For this reason, we recommend the previous step of recording the Excel file as a text file in CSV, separated value format. Then, to import CSV files, you can choose between different instructions: read.table, read.csv, or read.csv2. In addition, our libraries usually have databases for different topics, so that those who want to practice with these packages can use them as examples. To import data from libraries requires knowledge of them. A first option is to put the data instruction, with which different types of databases appear, including those contained in the different libraries already loaded. If, for example, you are interested on biomedical oxygen demand, you can write data BOD and next attach BOD in order to activate it. To better know the database, we use the instruction help VOD, which will lead us to an internet page with the description of the data, the type of format they have, the source where they are located, and references of interest. The Environment History tab stores an object value or function, among others, that we have created during our R session. In this case, we have different statistical data tables that we want to analyze. Let's see how to start working in R through a practical example. First of all, we define our working directory and then import our data file, in this case, a CSV file, and activate the data in order to work with it. We can also see the data in the Environment tab, and then the table with the data on the upper left side. This visualization helps us distinguish between qualitative and quantitative variables, which is essential to determine the subsequent descriptive analysis of the data. Once the data is activated, we can start working with the database. We first see the name of the variables with the instruction names, and then we can run str to know the internal structure of the table. This last instruction also helps us to detect the typology of each variable, qualitative or quantitative. The data comes from the Health Survey of Catalonia 2006, which contains information about the possession of a private health insurance and the health status of the individual. We observe that our database contains 21 variables. On the one hand, there are qualitative variables, represented by factors such as sex, with 2 categories, age with 7 categories, or civil status with 4 categories. On the other hand, there are quantitative variables represented by E, which means integer. However, we have to be aware that among these integer variables, there are dichotomous variables which can be interpreted as qualitative variables. This would be the case of the variables specialist visit, insurance, accident, activity restriction, hospitalization, tranquilizers, and drugs consumption. They only take 2 values, 0 being the negative response and 1 the affirmative answer. These variables are not real numerical variables, but they can be treated as qualitative variables. Knowing better our database, we can start exploratory analysis of some of the variables of the database that we have loaded. Tables with statistical measures and plots for the quantitative variables and plots and frequency tables for the qualitative ones. We are going to start describing qualitative variables. First, we need to install this package. Once the package is installed on the computer, it will behave like an internal package. If we want to use it, then we just have to load it writing library break package. This is the package for doing descriptive statistics, and it includes, among others, functions for creating weighted frequency, contingency tables of categorical variables, and plots. The first instruction we are going to use is frec, which prints a frequency table of a selected variable. With this instruction, we obtain the absolute and the relative frequency for each category of the qualitative variable. The default option includes also a bar plot of the variable. We can characterize the plot specifying, for example, the representation of the percentage instead of the absolute frequency, and even if we can specify the length of the y-axis. If you don't want to see the plot when running the frec instruction, you can specify plot equal false in the function. These instructions are also useful to make frequency tables of discrete numerical variables. In addition to the tables, we can make graphic representation directly using the plot instruction. In addition, if we want to make 2 graphics in a single image, for example, that they are next to each other, we can use the follow instruction, where we can define a row and 2 columns. To return the initial situation of 1 chart per sheet, the instruction is the following. As we saw in the previous video, numerical variables allow us to compute measures, position and dispersion measurements, and also to represent variables in graphical representations which are quite different from those done with qualitative variables. We will start by showing the results of the discrete numerical variables included in the database: number of rooms at home, mental health index, and number of chronic disorders. Then, we represent a box plot and a histogram of each of them. The instruction in R is hist and box plot. You can specify the level of the y-axis in the box plot instruction, writing this inside the box plot function. In this slide, we can see the representation of each variable, and with it, we quickly see how each variable is distributed. On the one hand, we see that the values of mental health index and number of chronic disorders are very concentrated in the low values. We can see this easily by looking at the histogram and also through the box plot, as the outliers appear only at the top of the diagram. This kind of distribution is called positive asymmetry. In addition, values of the mental health index are very concentrated from 0 to 1, as the 75% of the values, the box, are between these 2 values. In fact, what is observed is that 50% of the values are 0, as the median, the black line, is over this value. Then, the rest of the box, 25%, goes up to the value 1, and finally the other 25% of the values reach to the value of 2. This means that even if there are a lot of outliers, values have a low dispersion. In contrast, the number of chronic disorders has more dispersion. The range of values that the variable takes is more extensive, going from 0 to more than 10. If we focus on the box, we see that 50% of the core values between the first quintile and the third quintile go from 1 to 5, and the last 25% from 5 to beyond 10. On the other hand, the variable number of rooms at home is more symmetric, as it has outliers for the two parts of the graph. In this case, apart from the outliers, values are distributed in a more similar way. The initial 50% is between 1, the minimum value, and 4, the median, and the upper 50% between 4, the median, and 6, the maximum, before outliers. So, the box plot is a good tool to see in a visual and quick way how the values of a numeric variable are distributed. Apart from the graphical representation, as has already been said, with the numerical variables it's possible to calculate the statistical measures of position and dispersion. The instructions in R are summary, break variable, which gives us information about the minimum value, the 3 quartiles, first, second, or median, and third, the mean and the maximum value. If we want other measures, we can simply write specific instructions to compute them directly. These are the standard deviation, interquartile range, or the range. From these values, you can confirm some of the characteristics displayed through the above graphs. The clearest indicator is the standard deviation. Then, seeing this measure, we corroborate that indeed the variable number of chronic disorders is the one that presents a greater dispersion of the data, while the variable number of rooms at home is the one that has the least. The minimum and the maximum values also give an idea of the dispersion of the variables. So, again, if we look at the variable number of chronic disorders, the range between these two values is much higher than in the other two variables. Finally, the interquartile range gives information about the dispersion between the central values of the distribution, what is represented by the box in the box plot. In order to better show how to deal with numerical variables using R, a new variable has been included in the database. This new variable, called numerical income, has been constructed from the qualitative variable that we already had. The reason for this is that numerical variables included in the database are mostly discrete, so they are not so suitable to represent, for example, a box plot. Then again, we repeat the instructions discussed in the last slide to represent the histogram, an equivalent graph to the bar chart for continuous variables, and the box plot. In these representations, mainly through the box plot, we see the quantity of outliers, that is, there are few individuals with a very high income. Most of them have income between 1,000 and 50,000. This exploratory analysis allows us to see that to continue with any subsequent study, we would first have to eliminate these values in order for the analysis to be correct. The position and the dispersion measurements, again, corroborate this first visual analysis, giving concrete values on the dispersion and distribution of the data. Thank you very much for your attention, and I'm waiting to answer questions or queries that you may have.